Hello, everyone. My name is Salman Hameed. This is Chai on Science Communication, or we are trying to have a conversation about science communication, where I joined with science communicator Nisse Greenberg. He is he has worked with Story Collider, with the Moth, and brings a long experience of science communication. And our guest today is Ethan Siegel. He probably, many of you who are seeing and hearing, have seen him with his really fascinating, important blog or write up, Starts with a Bang. He also writes for Big Think. He has also written books, Treknology, the science of Star Trek from tricorders to warp drive and beyond the galaxy, how humanity looked beyond our Milky Way and discovered the entire universe. So, welcome, Ethan. And we just want to jump in. So, Nisa, let's start about how do we think about science communication?
Yeah, Ethan, I was thinking, I was watching, I was reading some of your stuff and watching what you were making, and you make a lot, right? Like you can attest
You,
to the idea that
I would be hard pressed to dispute you if you called me prolific. I
yes,
I certainly generate a lot of content. A lot of people who subscribe to me chide me for producing more than they can read. So I understand.
in that vein, I'm thinking about like what I'd just love to hear about is what is your decision making process on what you make content about, and could you just like walk us through sort of like how you make the decisions on what you want to talk about?
You know, it's obviously not like there's one overriding thing like
Sure.
what am I going to write about today, right? There are a lot of things that compete for our attention in the world and in our minds and in the world of science as well. For me, my background is I am a theoretical astrophysicist. I got my undergraduate degree in physics, I got my PhD in theoretical astrophysics through the physics department. I did a postdoc in astronomy. I became a professor of physics and astronomy, which I was for several years. But in 2008, while I was a postdoc still, I started getting serious about science communication. I started giving public lectures. I started my blog, which is crazy to think that this is 2024. And that was 16 plus years ago in January of 2008 that I first started writing. I made videos, I've written books. But for me, in 2015 was my last year where I was teaching as a professor, and I went into writing full time after that. So for me, I think all the time about what are things that I know and the community of scientists know that the general public should know? What are things that I think people who live in my little world all know about, but that the general public doesn't know or doesn't fully understand or doesn't appreciate? And that is like an endless reservoir of things to draw from. So I don't ever have a problem saying, like, what am I going to write about? I'm out of ideas. I never have that problem. My problem is, what am I going to write about today? What am I going
Exactly.
to write about this week? And so when there are new results that come out, if I think they're exciting, I try to present them, but I also try to present them in the context of what did we think about this field? And then what did we think about this field before these results come in? And then how do these results matter? I try to remember what it was like when I was younger and I didn't know about any of this.
Mm.
So I try and tell people I think of them like an intelligent Martian, someone with lots of intelligence but no experience. But every once in a while, there are also topics that come along that are making headlines, that are getting into the news, and I feel often are not being reported on very well. Where if you read what's being reported, you're going to walk away with an impression of science or the state of affairs of the field or a set of knowledge that is not congruent with what science and scientists actually think about this. So sometimes my pieces are reactionary, sometimes my pieces are on the cutting edge of news, but I think more often I try and think of that bigger picture of here's a thing that people all worry about. If you don't have any experience with this, how in plain English can you make sense of these concepts without the math, without the expertise? Because for me, this is not knowledge for just the few thousand or maybe 10,000 people who have their PhD and do active research on it. There's 8 billion of us out there. These stories, these scientific discoveries, they're for everyone. So I always think about things in context of how can I explain this to someone with curiosity and intelligence, but without experience.
And you're that I want you to explore deeper what you just said. You said this third category you were talking about, a thing people all worry about. How do you like determine what people are worrying about in physics of all things? Oftentimes is what you're writing about. How do you like try to understand like what is the culture really worrying about? What are people worrying about? What do they need to hear? Because as you said, it's an infinite amount of stuff that you could be talking about. There's not a limited amount of information in the world. There's not a limited amount of wisdom. What do you choose at this point? And if you want to talk about this, how has that shifted over the 8 years you've been doing this full time?
Oh boy. So right, there's a combination of things, right? There's what have other people said that you've likely heard, right? Have you heard about string theory? Have you heard about relativity? Have you heard about the Large Hadron Collider? Have you heard about the Higgs boson? What else? What do people think about that? And what should you think about that? What are the frontiers of science? I often think about like science is this huge landscape of a frontier, and I think about it like the inside of a cave, right? You go to the inside of a cave and scientists are explorers. We're exploring the edges of the cave. We're trying to create these comprehensive, refined maps of the inside of the cave. And every once in a while, you get a scientist with a chisel and a hammer that are hammering on the edge to see, can I create more cave? Can I increase the volume of what we know? And every once in a while, there's a breakthrough and you find, oh my goodness, I chiseled here and I'm through to the next thing and there's a whole new room in here to explore. And so I try and bring people up to these frontiers, but I also try and get them to marvel at the uncertainty, at the unknowns, because a lot of people think like, oh, science is the quest to learn A and B and C, and once we do, it'll be done. And then this field will be, we'll be done with it and we'll be ready to move on to the other things. And that's not how it is at all. Every time, almost every time we learn something new, it opens up a whole host of new questions. For example, we know so much about where our universe came from. We know so much about how things came to be the way they are today, but there are still these fundamentally unanswered questions, right? Why do the particles that exist have the properties that they do and not some other set of properties? Why is our universe and ourselves, why are we all made up of matter and not antimatter? How did that happen? Right? Why do the particles have the masses they do and not any other set of masses? Why right? There are all these questions I could ask. Why this way? Or how did it get to be this way? And for me, those questions are things that stay with me. They're things that physicists and astronomers and astrophysicists, we keep asking, because until we find a satisfactory answer, all we have are ideas and the limits of our knowledge. It's copious. Our knowledge is copious, but it isn't everything. And so when you start thinking along these lines of what do we know? How did we come to know it? What do we still have yet to discover? And how are we trying to discover it? That's where most of my story ideas in that third category, where I'm not chasing the news, that's where they come from. And some of this includes things that are historical stories where we thought things were one way, and then we challenged that idea, that preconceived way of thinking, and breakthroughs were made. So how did we do that? How did we overcome our preconceptions to make those advances. Because even though it might not be as famous as, hey, remember when Copernicus replaced Ptolemy? Like, okay, no one remembers that, but we can tell those stories. But we can, we're essentially doing the same thing today. We're looking for that next advancement. We're looking for that next breakthrough in the cave wall to try and find what else is there to learn, and how does our view of reality change when we learn it?
So if I can jump in, I mean, so first of all, I mean, I read your columns regularly, and I'm trained as an astronomer, and I find them very useful. So one question, of course, comes in terms of who is your audience, but I actually want to sort of like tie it in with uh, and in some ways this is the motivation of having conversation with you and with others as well who are practitioners of science communication, that we are now limited by algorithms, like that okay, so you have certain, if you have a video YouTube like we are in, or for example you are writing it, the topics, if they are click worthy, then sort of like you get audience. If you get audience, you get revenue, and so on and so forth. How do you balance that out? Or do you think, okay, well, here is an article that I think is going to get more views, but but I can tweak it a little because then it can generate a bigger headline, and so on and so forth. I mean, how much does that play, and in terms of thinking, in terms of what stories you are going to write?
I'm probably one of the people who's least concerned with that. I agree that this is important for getting clicks, because if you write the greatest piece in the world, or you give the greatest speech in the world, and nobody hears it because you didn't capture your audience, what's even the point? Um, but for me, that's not really where my strength lies. I know that's not where my strength lies. And, your whole life, whatever it is you're involved in, you have the things that are your strengths, and I think you should play to them. And you have those things that are your weaknesses. And yes, you can spend some time and effort shoring them up, but don't devote all of your efforts to that. You will never excel at that. If these are your weaknesses, become competent at it, but stick to your strengths, play to your strengths. I remember, this is a weird story, but I remember a little more than 20 years ago, they were celebrating the 20th anniversary of what was called the Miracle on Ice, which was in 1980. The United States men's hockey team, made up of amateurs, not professional hockey players, made up of amateurs, took on the Soviet Union at the Olympics, and they won in a huge upset. And when that happened, the announcer, Al Michaels, the big announcing, he said as time was running out and 4-3 was the final score, "Do you believe in miracles?" And then, slightly later, there was the gold medal game against Canada, which was another miracle and another come from behind victory for the United States, and they won the gold medal at the Olympics. 20 years later, they're going to make a movie about this, and they try and reenact it. And they had this debate when they were casting for the movie. Who are we going to get to play these young hockey players? You can't get the old hockey players because they're old. These are young kids in the Olympics. They're amateurs. So what do? Are we going to cast these young, famous actors who are going to draw the audience to the box office because of the name recognition and the pretty faces, and this is who's going to come see the movie? But then we have this drawback of we have to teach them to play convincing level hockey, right? Someone's going to watch this and be like, well, these are actors, but are they really playing hockey? It's like if you watched Cinderella Man, with Russell Crowe as a boxer, Jim Braddock, and you watch the boxing and you're like, oh goodness, Russell Crowe can't box. Takes you out of the illusion very, very thoroughly. And so then they said, well, the other option is we can get hockey players, right? People who've been skating since before they learned how to walk, since before they learned how to crawl, they've been skating. And then we can teach them to act, right?
Mm-hmm.
And which one's harder? Is it harder to teach actors to play convincing hockey, or is it harder to teach hockey players to be convincing actors? I am a scientist. That's how I'm trained. That's what I've worked on. That's what my background is. That's where my biggest strength is. Communication, I'm good at it. I'm not the greatest communicator of all time, but I'm competent at it. I've worked at it. I've developed skills at it. I might have some amount of talent at it, but I know I'm not as talented as a communicator as I was as a scientist. But still, this is something where I feel, most of the people doing science communication, they're not scientists themselves. They're not steeped in this. It's not baked into who they've been their whole lives. So for me, I try and think about, look, the package is important. I'll work on making it good. The how it's packaged, what the headline is, what the title is, right? If someone says, like, I read this really interesting article that you wrote and I loved it, but the title, oh, that was a little clickbaity, right? That's not an insult to me. That says, oh, I did something good with that title because it got people interested enough to come and check it out. And then once they were there, they had the opportunity to learn something meaningful. So I don't focus as much on that. I know plenty of people do. I know plenty of people who, by those metrics, will be more successful. But I would rather be Ethan Siegel producing things of incredibly high quality and scientific value than Arvin Ash, who's going to get an amazing number of views on his videos, but who doesn't have the depth or breadth of knowledge and the ability to sort of know what are the essential important points that we should be sharing with people and what are people clamoring for to try and understand, and how can we give them things regardless of what level they're at that are going to enhance their view of the world. So, Salman, that's a really good point that, yeah, I should probably be better at that, or I should probably get more people on my team who can help me out with that. But my focus is on the quality of the science communication and the science being communicated. And sometimes it's like throwing spaghetti at the wall, wet spaghetti at the wall. Some pieces will stick and they'll do great, and other things that I thought were just as good a quality, they didn't stick, and that's okay. Because I'm so prolific, you have to concentrate on the victories, forget about the defeats, and move on with the motivation to create something new.
Can I approach that from a different thought? If you think about, because the Miracle on Ice story really resonated with me, of that, like, what I've done with my life over the past 15 years is I've been the one training scientists how to act, essentially. And like, I used to be the one who was I was doing performance, and I was the nerdy scientist out of the performance. I was teaching high school math at the same time. And so people saw me as the scientist. Me teaching high school math does not make me seem like a scientist in comparison to like the science world. And I became instead the other side of that. And I'm curious, from your perspective, going from being a professor, being really in academia, and then going into this science communication world where there's a very different set of barriers of entry. So there's a different group of people you're dealing with in both scenarios. How have you noticed the incentives change for you on what you think about, how you talk about it? Like, internally, what do you notice shift in terms of when you were a professor, you were trying to publish in the very like publishy world, and now you're trying to create content, and like, what are the different incentives between the publishing and the content, if that makes sense?
Well, the biggest difference between that is when you are in the publish mindset, you're on the lookout for what is new. What is a new thing where I can contribute something novel, something that no one else has done or said before? What is a thought that I can have that's going to push the field forward in a new direction? And when you're a science communicator, that novelty, that I'm going to add my own twist and my own spin, is actually a negative, right? That's
Right.
when you start doing that, that's a value minus, right? Because no one is interested. I mean, some people are interested. Most people are not interested in, hey, what's your personal take on how this is going to go? What's your personal perspective on what the next big breakthrough is going to be? That's not an incredibly useful thing for a science communicator to focus on. What's more useful for a science communicator to focus on is, what do we know? What is known to scientists, and how did we get there? And now, what is the general public's level of knowledge with this? Because my approach to telling stories about science is, I want to start down here where the general public feels comfortable, right? Whether they know something correctly or not, if they feel comfortable here, that's a good starting point, right? People feel comfortable thinking about the Big Bang, even if they don't think about it the way scientists think about it. People don't feel comfortable thinking about string theory because they don't have a picture in their head of what that's like. People only feel a little bit comfortable with the idea of dark matter, right? So if I want to talk about that, I have to start at something that's more basic. I can talk about a galaxy. I could talk about a cluster of galaxies. That's something they feel a level of familiarity with. And then my goal is saying, well, look, you want to get up here. You want to wind up talking about this level of thing. I can't say we're going to start here and then take a leap up to here. I'll lose my audience. So what I instead have to think about is, well, if I can start out here and then I just can take one small step to get up to the next place, what step can I take to get us closer to that goal that people will still feel comfortable with, where they feel comfortable with that step and this new level? And if I do that 5 or 6 times over the course of an article or over the course of a story, then we can get all the way up to where I want them to be. So a lot of times people complain to me, Ethan, your stories are always like 2/3 background, and the new stuff doesn't show up until I get to the end. And I'm like, and that's why it made sense to you.
Yeah, right.
So actually, so can I? By the way, I'm still thinking about Miracle on Ice. I mean, I think that was just a great example. No, I think if I can follow up on this thing and with a more
And
concrete
don't
example.
second guess yourself. Don't be like, oh no, am I the hockey player who can't act? Oh no, am
Right,
I the
right.
am I the scientist who can't communicate? Like, don't have those moments, because I get it from both sides. I have
Right,
journalists tell me I'm not a
Yeah.
real journalist because I didn't
right.
go to journalism school. And I have scientists tell me I'm not a real scientist because I've been doing journalism for so long. So
Mhm.
don't don't fool yourself into believing that because you did this thing, that if you're not actively doing it anymore, that you don't still have the skills and knowledge that you had when you were doing it. And if you're doing something for a long time, don't let yourself believe that you don't have that expertise because you weren't trained the way that other people were trained doing it. You are the amalgam of all of the things you have learned and done over your life, and that helps inform what you can do today.
Oh, that's fantastic. So if I can go with a specific example, and uh, that you were talking about, sort of like, how do you, that as since you don't publish, so as a writer of or science communicator, the innovation is not is it's almost a negative side, right? So if I but however, when reading your columns, I found some of the things really important in the context. And you have a recent article out critiquing Avi Loeb. So he's the Harvard astronomer who has claimed about various things, including aliens being sort of like, responsible for a comet and alien spherules found here on Earth, or alien technology. But when you approach that, and you have done multiple articles on that, and those are in a lot of detail, and the way you present it, there is a lot of analysis that is taking place. You do take into account what are the experts saying about that, but you are also commenting on philosophy of science in that sense,
Mhm.
or how science is done. Do you think that is something that you would consider yourself as part of
Hmm.
contributing to the field in that context? In taking a step back when you are in astronomy, when you are or in physics, you are narrow, sort of like, you have blinders on top, and you go like, okay, I'm doing this, I'm just communicating with the people that are fellow scientists or fellow astronomers or fellow physicists. But you have to take a step back, and then you do have to analyze and think and perhaps create new form of knowledge when you are taking that and approaching at a bigger scale. Do you think that is the case, or do you think that would still be considered as sort of not summarizing, but sort of like a distillation of ideas?
The way I think about that is not where I really consider myself a philosopher of science in that sense. I would say I consider myself more of one of my strengths is the ability that I have a very broad knowledge of these fields. Not perfect, right? I know much more about cosmology, which is what my PhD was in, than I know about planetary science, which I only have a peripheral knowledge of, or then string theory, where I would say I probably know as much string theory as a second or third year string theory grad student, which is an incredible amount compared to the general public, but is a negligible amount compared to a string theorist. So it's important, I think, to be aware of where your own knowledge leaves you in terms of what do I need to know? Because one of the huge things that you need to be able to do to be a good science communicator, and there are probably going to be some science communicators that listen to this who disagree because they are not good at it, is you need to be good at learning what you need to know in order to explain this to others. So you need to have that self-awareness to know, where does my knowledge end? Where are the gaps of my knowledge? And then who can I go to help fill those knowledge gaps in? What are the things that I need to learn in order to put all of this together? Because the key is not, oh, I need to show someone how the process of science works, or I need to show someone what it's like to be in these weeds. The key for me is being able to synthesize, this is what everyone's starting point should be. And then, okay, well, if we're looking at this aspect, then how do we proceed? How do we go to that next step? And then what are the responsible ways to do that? So I really think that I guess I think of myself as a synthesizer of, oh, well, here's how scientific knowledge, here's how we obtained it, here's how it came to our lives, here's how it came to our field. Then what are the next steps that we took? What did we actually learn from this? What does this mean? Right? You collect data. Here's what the data allows you to conclude. And you might have these speculative ideas, but you need to be able to discriminate between them and tell them apart. And how do you test it? How do you tell which is correct and which is not? What evidence do you look for to discern between what was possible but isn't reflected by reality versus what was possible, or maybe what's even surprising, but that the evidence supports? So it is this intellectual exercise, but it's also an exercise in humility, because you have to be humble enough to say, here's what I think I know about this field, but I have to keep my mind open that I know I don't know everything. I recognize that some of the things I might think could be wrong, um, but I need to be able to go to who are the bona fide experts and ask them when I don't know, what are the frontiers here. And you also have to be very aware that there are a lot of people who are much more interested in self-promoting their own ideas than in telling you what is true, which is why going to one source, going to your favorite source over and over again, is not always the best option. It's usually better to have a variety of experts that you can check with each other, because that's how you get an idea of what is a consistent picture. My least favorite science communication headline is A, where A is some authoritative sounding figure, says B, where B is an unbelievable claim that is not supported by the evidence. And I think our society is worse every time an article like that gets written, because I don't care who A is. A doesn't matter in the terms of science. What matters is what is the claim of B, and how does the full suite of scientific evidence support or is consistent with or completely refutes the idea of B.
Well, to come back to, I'm really curious as you're talking, and let me know if I'm interpreting you right. You earlier you said that like when you're a science communicator, it's important sort of not to innovate with the science, right? Like you're not there to create new science. You're there to listen. Am I interpreting that decently?
Yeah, I mean, you don't want to hear my opinion on, oh, well, we saw these hard and soft X-rays coming from this location in sky that also has a galaxy. You don't want to hear the Ethan Siegel interpretation of what
Right.
those X-rays mean. You want to hear, oh, well, who are X-ray scientists who study this, and how do they interpret that data? Right? You would
So
much rather hear their interpretation than my interpretation, because I am not an observational X-ray astronomer, and my interpretation is going to come with much more limited sets of knowledge than their interpretation does.
so you're synthesizing scientist information, and as the communicator, that's your job, is to synthesize and then put out. And I'm curious though, simultaneously as you talk about communication, you start talking in very like, we should do this, we shouldn't do this, which in a lot of ways uh, this is your innovation of science communication. This is you putting your mark on how we should talk about science. Where I guess the question that I'm curious about in this is, where have these ideas percolated from? What has given you this perspective on how science should be communicated? And then how do you sort of square that circle of like, this is now my field, that I'm going to innovate within the field of communicating. I'm going to use your metaphor. I love that chisel at the edge. The science is chiseling at the edge of the cave. And it felt like when you were talking about science communication, you're saying that's where you just shine a light on the chiseling. You say that's where the chiseling is. Now we can see the crystal behind the wall or whatever. What if within that cave, the shining of the light means there needs to be this new form of chiseling to create the light in the first place? What type of light are we shining? How strong is the light? Like, to keep this metaphor going far too long, like what do you see as the ingredients of that light, and how has that shifted in your mind?
You know, I think this is a hard question, right? And I'm going to pull you out of your frame a little bit, and I'm going to move things around because I don't think about it that way. I don't think that science communication is a science. I think that science communication is an art.
Cool.
And I think when I talk about a responsible way to do it, I mean a way that preserves the integrity of the science. There are multiple different styles that can do that. I remember Sabina Hassenfelder, who is maybe not my biggest fan, once said of my writing, I from her I took it as a compliment, but it's as always pretty backhanded, right? She says, "I don't like Ethan's style, but at least he has a style."
Mm.
and and I said, all right, well, this means that someone is looking at my writing and saying, I recognize this style of writing. I recognize that he has a voice, that I can tell it's him and not someone else. And for me, that is like, oh, that's an art form, right? The
Mm.
communication is an art form. I think there are many different ways, just like, what kind of foods do you eat? If you want to go to any number of nutritionists, or nutrition adjacent professionals. They'll tell you how you should eat, what you should eat, when you should eat, how much you should eat, right? They'll tell you all of this. But we all know that the truth is uh, what's healthy for me to eat may not necessarily be identical to what's healthy for you to eat, to may not be identical to what's healthy for Salman to eat, right? We might have different bodies that vary from person to person. My style of communication may not resonate with everybody. Um, but it's not my job to prescribe to everyone, here is how you do this. It's my job to say, look, here are some parameters that if you go outside of these parameters, I can immediately recognize this is very irresponsible. You're not accurately representing what the science is, what our knowledge is, what this study is about to others. Um, but if you fall within some basic parameters, I look at the rest of it as an art form. And so for me, I look at writing an article, telling these stories, it's a fundamentally creative process. So I have to do it in a way that my sense of scientific integrity remains intact for it, because I fundamentally believe that anything you're going to do, you should try and do it with excellence. And that's just how I live my own life. But as far as the specifics, you can try different styles. You should experiment with them and find what's right for you as a communicator. Because communication, I really do fundamentally believe it's much more of an art form than it is a science. There are many ways to tell a compelling and accurate story that can not only engage the audience, but can teach them something important. The exact details of how you do it are going to be specific to you, just like Nisse, if you are a math teacher, there isn't a formula that you can do for how do I teach these students, right? You're going to take many different approaches with them, and hopefully there will be one in that set of techniques you use to them that you expose them to that's going to resonate with them. Some of them might benefit more from a graphical interpretation. Some are fine with algebra. Some need numerical examples, right? There are all sorts of different techniques you use, and in my experience, it's a variety of techniques that you use that are going to give you the best outcomes. And I think it's the same with science communication. I don't think there's a formula for here's how you have to communicate science. I think, look, there are a lot of ways to do it. I have a style that I'm possibly most comfortable with, that works for me, but that doesn't mean everyone else should do it that way.
I'm so curious, but from everybody, this is like bringing up something that always comes up to me, and I just want to drop this little seed for us to think about. Of like, I love what you're saying about art. That like, and you're absolutely right. When I teach math, I used to think of it as concentric spheres. That knowledge, the way we think of leveling up in math, especially at high school era, is like concentric spheres, and every student has like different holes to get out to the next sphere, and you're just looking for where the hole in the sphere is. And some students have a lot of holes to get out because they like can learn in many different ways, and some have like one way that they need to get out of that sphere. They're not going to be able to move on to the next thing. And so I love that because you try so many different ways of with art. It's open to interpretation. And with science, at least historically, we have not allowed ourselves that freedom of creativity in the same way. We have the scientific method, right? A singular way. And I'm curious. I think we all know that it's a little more fluid than that. And I just want to like drop it. Maybe is there many different ways to do science too? Is there style? Is there style? Does science not function the same way? Do we not have style for the way we do science?
Let me ask you this. I don't know how much quantum mechanics you learn,
A bit.
but maybe you have heard that there's this problem in quantum mechanics that, in our 3D universe, you are used to taking an object mathematically. If you rotate this object by 360 degrees, everything about the object is the same
Mm.
as before you rotated it 360 degrees. This is not true in quantum mechanics necessarily. There are some quantum systems that if you rotate them a full 360 degrees, you get the negative of what you started with. And this has to do with quantum mechanics obeying complex number systems instead of real number systems. And so some people explain it mathematically. My graduate quantum mechanics professor explained it to me. His name was Kevin. And he said, so if I rotate by 360 degrees, evil Kevin. But then if I rotate by 360 degrees again, oh, now I'm normal Kevin again, right? And does that explain it? Well, for me, that wasn't the best explanation. I heard another explanation later on by a mathematical physicist that I met named Jerry Golden. And Jerry Golden said, go back to your coffee cup. Take your cup and put it in your hand. Oh, God, I hope I don't drop this coffee cup. All right. He said, now take your hand and rotate it with your palm facing up by 360 degrees. All right. What has happened to your elbow? What has happened to your elbow? Oh no, your elbow is facing up, but go ahead and rotate it by 360 degrees
Oh wow.
again.
Yeah, that's
And look
interesting.
at that. It's facing down. Now, let me ask you, does appealing to the complex plane, turning around and making a face, and rotating a coffee cup with your elbow, are all of those identical? Or do those different explanations make you think of something different with each one? And do some of them resonate more clearly with you as a more robust analogy of what's happening? I'm sorry for turning this into a science communication lesson.
No, I love that. I think though it's still communicating, and I'm like still stuck on this. I thought of like I think my headline, if it gets written about me, is the science communicator says scientific method is bogus. You know, like that's the clickbait headline. Is like what if there's many different ways of approaching this? I don't know.
Well, I mean,
but those are,
scientific method's a real thing, right? When people ask me about what science is, I always tell them it's two things at once. One is the full body of knowledge that we have
Mm.
through all of our observations, measurements, and experiments over the whole history of everything. That is one thing that science is. Science is this body of knowledge, but
Okay,
science is also a process. It's also this process of how we learn, how we gain that knowledge, how we take those new steps. And
so
so for it to be both of those things together, yeah, I can add more to it. Obviously, science is much more than just those two things. But I think if you take those two things and fuse them together, that's most of what science is. And it's enough to get people comfortable with the idea of, oh, I could contribute to science too. If all of our scientific knowledge was lost, right? Someone Library of Alexandria did it and it was gone. Um, with just those two things, that notion that we can go out and measure the world and observe the world and take observations and conduct experiments and build up a suite of knowledge, and then we have this investigative inquiry based process of looking at the world and the universe that's going to allow us to build a, not just a house of cards but a robust foundation and a solid structure atop it. We could reinvent all of science at any point.
mm.
And I think that's a very powerful idea. Salman, you look
and it's
like you have
also,
something you want to say.
well, I was just gonna say, like, but also, I mean, science is very broad as well. I mean, so you have different ways of approaching different aspects of science. So the way biologists, for example, approach it would be different, or geologists would be perhaps be methodologically different than the way astronomers might be doing it, although underneath there would be a similar way of thinking. Is that sort of like, Ethan, would be more sort of like accurate way, or and we can even go with evil Kevin, for example. We can go into the psychology. So psychological sciences, for example, go even in a different way. So the methodologies might be different. So there is the scientific method. I mean, there is no single scientific method, but rather there are methods to do science.
Yeah, I would say what I outlined is a general method for what science is and how it is done. But within each field, you have much more specific breakdowns of what are responsible ways to do it. And I think this is very important when you go into a new field. You should learn very thoroughly what are the responsible ways of doing science in this field, because one of my, I guess, pet peeves is when people from one field of science stumble into another field of science and tell everyone in that field, you've all been doing it wrong. Here's how you do science, because their method is different than the method that is used in this field. You should be very, very careful to make sure that you have a healthy respect for the experts and the expertise of people who are working in their fields. Because in every case that I've seen, and look, I wasn't alive back when like people were like, oh, you can't put the continents together. Continental drift is crazy. Like this is ancient history. In the past 70 years, there are like no examples of, oh, we've done our whole field of science wrong. Maybe in fields of science that are in their absolute infancy, like fields of science that are where astronomy was like 4,000 years ago, which might be some fields. I don't know how
I mean,
robust the foundation of
I
like
would,
evolutionary psychology is. I don't
yeah, that's
know
where I would,
how robust the science of economics is, right?
or
I
statistics.
wouldn't be
Statistics
surprised
in
if
general.
people said, yeah, we thought this. If people 100 years from now were like, yeah, that wasn't a science back then. That was like a barber was a doctor because they had the sharp tools. Come on.
Right, right.
um so I can't really speak to these fields of science or of science in their infancy that I don't know very much about. But I do know many examples of like physicists who get involved in climate science, and climate
Mhm.
scientists are very upset because physicists are being critical of absolutely irrelevant points to the enterprise of climate
Mhm.
science. And it's the climate scientists, not the physicists, who are correct.
Can I ask you another question, but rather than from the perspective of sort of like people jumping in and making mistakes? Obviously, you have to know, and sometimes those are very simple mistakes that if you're not in that field, you don't realize it. But you also wrote, and I thought that was important, uh, a piece about the fact that James Webb Space Telescope is discovering galaxies that shouldn't be there. And the original paper got published, like, that they were, so the idea was like, that James Webb Space Telescope is pushing our boundaries of knowledge and it is detecting earliest galaxies. And a, f- a few papers came out that said, well, those galaxies should not exist. And I've been pretty critical of that interpretation as well. Sort of like, no, yeah, I mean, there are interesting questions, but here is a case where the experts who
Mhm.
are studying those galaxies are making claims that don't that may be an exaggeration. So it's a different type of a problem. So if you go like, okay, well, what do experts say? Well, these are the experts. These are the leading people leading the proposals for doing those observations, and yet the way they are interpreting them may be a problem for and the way they are interpreting for, especially for the public consumption. How do you
Mm.
see a difference in there, or do you see, does that fit into the same category? How do you categorize that particular type of I guess translating it to the public?
You have to be very careful with that. For me, my background is as a theorist. And so I'm well aware that if you go to an observer and you say, what did you see? They will be able to very accurately tell you what they saw. If you go to an observer and you say, what do your observations mean?
Mm.
The community of theorists will not necessarily agree with what the observers tell you that their observations imply. So you really have to know enough to say, you are reliable for this category of things I can ask. And I want to hear what you have to say about these other things. But I cannot just take what you said about what it means and publish it uncritically. I have to take a look at, hey, there's this huge context of things. So, if you say these galaxies shouldn't exist, well, why? Like, I remember being in elementary school. I think I was in third grade, and I was barely 4 feet tall in third grade. Um, and this one person in my class was the same height as my mother. They were about 5'2". And I thought, oh goodness, I'm in this class with an adult. Why is there an adult in my class? And it wasn't an adult. It was a tall child.
Yeah.
Children come in a wide variety of heights. Some are much shorter than average, some are much taller than average. And when I was 7 or 8 years old, I had a very tall child in my class. If I went and looked at the early universe and I saw a galaxy that looked like an adult galaxy, I would understand why an observer would say there shouldn't be adults back then. The universe was like 5% of its current age. What is an adult doing back there? You can't be an adult back there. Well, maybe it's just a tall child. How we know nothing about the population of these young children that existed back then. In fact, we have astronomical bias in our equipment that it's much easier to see the tallest children that existed back then. So I think this is the sort of thing where you have to be extremely careful. And that involves understanding what it is we are uncertain about and where those uncertainties lie. And oftentimes, the people making the observations are not the people who should be drawing those same conclusions. For example, you have people who study quasars and gamma ray bursts and say, oh, look, we see these quasars and gamma ray bursts associated in this sky. And look, here's them in the shape of a ring that's 10 million light years across. And here's them in the shape of a line that's 12 billion light years across. And they say, as observers, we have discovered these structures, and these structures are so big they shouldn't exist. And then you go and you talk to a theorist who studies the large-scale structure of the universe, and they will tell you these things are structures the way if you mapped out all of the pink mansions in the United States and found a cluster of them from Atlanta down to Miami, you said, oh, look at that structure. There's a structure of pink mansions that shouldn't exist. Well, hang on. You're making some very biased observations here. And if I actually looked at a map of housing in the United States, I would see there is no structure there, that these things are not tracers of structure. But people who study quasars and gamma ray bursts and do their statistical analysis, they're not accounting for that type of bias. So you have to be very careful with who you trust and about what. Are those gamma ray bursts? Yes. Are those quasars? Yes. Are they where they say they are? Yes. Does that mean there is a structure there? No. And you have to be the one who does the due diligence by putting all of this into context, by going and, like I said earlier, synthesizing all of these different subfields of science to make one coherent picture that is consistent with everything that we know.
I should say I agree with you, but I should defend the observers as well, because I was an observer as an astronomer, and we used to say, for theoretical physics cosmologists, we used to say cosmologists are often in error but never in doubt. But that was but more sort of like, but I agree with you. I sort of like, that.
No,
That
I
observers have to be
did
thoughtful.
do an
Yeah.
observational project. My very first scientific paper was an observational paper, and that's almost worse because I know, oh goodness, why did we say that? Why did we believe that? Why did we think that when we saw this line in this population and then we look at this other population, why do we think it follows the same line, right? And they told me, like, as an observer, it's good to ask these questions, but it's also good not to think too much about them. Just draw the line and make the fit and publish the paper. And so that is good because it does advance science in a specific way, but also that doesn't mean everything is right. For example, Vera Rubin, who discovered this very important stuff about the rotation curves of galaxies. We use this as some very strong evidence for dark matter. Vera Rubin herself never thought that the dark matter hypothesis was a good understanding. That doesn't mean Vera Rubin was right or wrong about dark matter. It means Vera Rubin's work was incredibly important for what it revealed to us about the behavior of galaxies. That is the important aspect of her work, not so much what she thought it meant. And I think that is something that everyone needs to sort of be humble about, is one observer's interpretation of their data is not worth as much as let's bring all of the data together in the context of our current theories and see what direction that leads us in, what remains possible, and how can we discern between the different possibilities.
I I want to like take a step into the to abstract this a little bit, this whole conversation into what I feel like we're circling and talking about is the responsibility of communicating versus the responsibility of science, and that there's this little shift in how what are the ethics around the communication of science, and how it's a little bit different than our ethical frameworks that we have when we're um, doing the bench science, sitting down and like looking at the data. How we communicate it with the public has like a different set of principles. And I think what it's making me think of is something I used to say to a lot of my math students, actually, is that like one of my favorite mathematicians is Pierre de Fermat, not because he was so good at solving things that had never been solved, but because he asked questions that nobody was asking. And it's such an interesting, different thought process around math, especially at that age. You're told you are good at math because you're solving a problem. When I wanted to tell these students, you're good at math if you're thinking of the right questions to ask. And so I wonder, Ethan, for you as you're doing this work in communicating, have you noticed yourself? Have you noticed a framework for yourself as to how you think of which questions to ask, which research holes you go down, where you get to the point where you go, actually, I need to stop looking at this. This is just my obsession. I need to think about something else. How do you think about the questions you want to ask yourself?
I really don't. That's not something that really is part of my process here. I really, that's not something that enters into my head. And I'm someone who likes Fermat a lot as well. In fact, when I was first asked the question of if you could have a conversation with anyone, living or dead, who would it be? This is way before I knew that everyone says Jesus and Einstein. This is way before I knew that, right? They just asked me this question for the first time, and I thought about it, and I said, Fermat, because I want to know what he would have written in that margin if he had room. Right or wrong, I want to know what you would have written in that margin if there was enough room for that proof of your last theorem, right? Everyone assumes it would have been wrong, and I guess I do too, but I still want to know what were his thoughts on that. But what I think about, what I always come back to is what people say doesn't matter. If every scientist, if you were to forget all of their names and only remember what they did, only remember what we learned from what they did, we would lose no knowledge. there would be nothing lost by forgetting everyone's name, by forgetting who did what, right? In the world of science, this publish or perish culture, this is what people are concerned with. Is this a career making paper? Is this an impactful paper? Is this my chance to become famous? Is this my chance for money or power or to get a grant approved or any of these things that scientists care and worry about? That's what they have to think about with their careers. As a journalist, as someone who communicates science, I don't care about any of that. I mean, I obviously don't want to tank the careers of the people whose work I'm highlighting. I'd rather, give them the credit that they're due. But my big concern is, let's tell people what is true. What is true? What is verifiably true? What is true, and how do we know that it's true? Let's teach them that. If we're wondering about something, let's show them how this thing is possible, and then let's unpack what those possibilities mean. But let's do it in a way that's truthful and accurate. That's what I care about. I care about what is true. I can make it interesting if I can do a good job of, of communicating it. But I don't think I worry about, like, oh, am I asking good questions or not? I think any question that gets at that core of what is the truth about this and how are we going to try and find out, that's good. That's good. That's good enough. It's certainly good enough to make a story out of it. But that focus on what is true, how do we find out? That's something that you cannot lose sight of. That you lose sight of that, and what you're communicating isn't science anymore.
Okay. And if I follow up on that, and we should be wrapping this thing up too, because it's been a while. But a fascinating conversation. But if I can ask again, I mean, things have changed over the last, since you've been communicating as well, but in general, and they are changing fast. The landscape is changing. The way we communicate is changing. Are there things that you are sort of like, looking at positive things that are happening, but also what are your concerns in terms of the way science communication is happening, and especially with different types of medium coming in and things like that? Do you worry about something? And you yourself have changed over the last 10-15 years. Are there things that you used to do it differently, now you are doing it differently, and you worry about what's going to happen in the next 5 years?
Worry isn't going to get you anywhere good. So I try and stay away from that. But you're right. The landscape of science communication has changed enormously over our lifetimes. It was in 2009 that CNN laid off Miles O'Brien. And for those of you who are like, what the heck does that mean? Miles O'Brien was the last dedicated science reporter to be part of a mainstream television program. That is 15 years ago since we had a dedicated science reporter regularly appearing on television. We have not had a single one since then. So, landscape has changed a lot. My concern, what I see as a problem today, is there is a lot of high volume, low quality noise. And a lot of people not only don't know where do I go to get what is true, I think a lot of people don't even value what is true anymore when they are faced with this overwhelming noise landscape. But I think if you go to individuals and you ask them, do you care about about being informed with truthful information, the majority of people would say yes, even though they might not know the difference between truthful information versus anything else, propaganda, someone with an agenda, someone profiteering off of you. They don't know. A lot of people, they go with their gut of what makes them feel good. And let me tell you, your gut would not tell you that it's possible to rotate something 360 degrees and not get back the same object. You start learning quantum mechanics, you'll never trust your intuition again, because well, I think it'd be this, but I better do the experiment to find out, because nature's going to surprise me way more often than I anticipate. So that's what I try and do. I still think there is room for what is true to have an immense and unique value that any sort of other type of information is not going to be able to match. So I think as long as there are people out there who value what is true in the world, whether it's through the written form, through podcasts, through video, through TikTok, through a YouTube short, through making a feature-length film, it doesn't matter as much what the medium is. What matters is if you have a high-quality message to deliver and you want to add your own artistry to it, go ahead and do it. That's a valid way to communicate. I can't promise you'll be successful. There are plenty of ways that I look at myself and I'm like, well, I'm not successful on these metrics, but you can look at all sorts of metrics and always say you have room for improvement. We all have room for improvement. That's why we keep trying. That's why we keep living. That's why we keep learning and growing. So, don't let yourself get discouraged by, oh, the landscape is different. I'm a dinosaur. I'm going to get left behind. Like, no, keep doing something of value and, and learn as you go. And you have the potential to go somewhere very far with it. That's what I would say to that.
Well, thank you very much. Nissa, do you have any other questions, or should
No,
we wrap it
that's
up?
such a beautiful rallying cry
Oh,
to add more music to the noise, get some harmony into this noise of because I feel you. There's a lot of people doing science communication, and I would love a little more harmony in it, a little more understanding of like, why am I doing this, and how are we interacting with each other, and how are our different methods happening in such a way that they can be synchronous, as opposed to just noise. And I love that rallying cry you offer.
Well, thanks for a very charitable interpretation of what I said. I appreciate it very much. I know sometimes I can come off a little bit curmudgeonly because you look at the people doing it wrong, and you look at the people who are just in this to increase their own fame, their own glory, their own, notoriety at the expense of what is actually true. I would be so happy if 100 years from now, no one remembered me or who I was in the world, but they remembered the things I tried to teach them. If people remembered that, if that lived on, and if that became part of the general knowledge, I would, I would think, wow, what a good contribution I left to the world.
well, on that note, thank you very much. And for people who want to see Ethan's contributions to the world, they should check out Starts with a Bang. We're going to put a link underneath the video in the description as well. And it was really fantastic having a conversation. It was really intellectually rewarding. And really, thank you for that.
Well, you're very welcome, and I hope to some of you listening out there that you take away some encouragement from this as well. There's still room for truth and knowledge in the world, and if you are interested in it, it's out there, and there are people working to bring it to you. So try and cut through the noise, and we'll try and keep you informed.